Yes, it is recorded.
Okay, thanks. Okay, so welcome everyone to this talk, and welcome and thanks to Gyanendra for agreeing to give this talk. I think a lot of people are interested to understand like what are these machine learning tools that are available at Splunk. You know, Splunk is a very popular tool for observability. This is a great. It's great that Gyanendra is able to find some time to speak to us on this. Um, okay, so a little bit about our meetup group. So we are the AI in Testing and Testing AI meetup group. Previously, we called the Testing in AI and DevOps meetup group, but we changed that name earlier this year to reflect more of the growing needs of the community. So a little bit about who we are. So this is me. My name is Himing or Chris Fu. I'm the chief instigator for most of these meetups. And then we have Jason Arbon, who is the founder and CEO of Test.ai, and he's also the co-author of the book, How Google Test Software. And he's one of our very important advisors for the group. And we also have Ron Brashear, who's a VP at Hewlett Packard Enterprise, and he's a very strong supporter and also an advisor. And he also sometimes co-hosts meetups for the group as well. So, we are always looking for help from anyone who's willing to volunteer their time. So we are always looking for meetup venues. Hopefully, this whole pandemic will be over soon. We can actually go back to actually having physical meetups. One thing that I think we miss is the human interaction. Before meetups, mingling and networking with people that we've never met before. And then also, once we have the actual physical meetups, we'll be looking for sponsors for food. Now, if anybody's interested to volunteer in any capacity or is interested to speak, please reach out to me via the meetup group. Happy to discuss with you what's possible. And lastly, many thanks to, okay, not lastly, this is second last. Second last is I'd like to thank my company, Climate, for allowing me to do what I do for this meetup group, allowing me to spend time to do this. So we are in the digital agriculture space. For those of you who are interested to find out more, just go to climate.com, and we have a lot of interesting stuff if you're interested in agriculture to see over there. And lastly, but not least, I'd like to thank AICAM, especially Bill, for supporting us, partnering with us for all these meetups and allowing us to be hosted on their Zoom platform. So without further ado, I will hand off to Gyanendra to speak to us about all this interesting stuff.
Hey guys, hello everyone. So my name is Gyanendra, and I'm a senior product manager in Splunk. Today, I'm going to give you an insights on how do we, I'll give you insights on the Splunk and also about the machine learning toolkit, which sits on top of the Splunk, and you can actually build and create models within the Splunk ecosystem. I think in the terms of the agenda, I'll come to that point, but let me share my screen. And also just for the internet stability, I have switched off my video. Once I'm done with my presentation and video, I'll switch it back. So just a moment. Can everyone see my screen?
Yes.
Okay, all right. So today I'm going to talk about the getting more from your data with machine learning, and especially in context of these Splunk. But before I move ahead with it, some forward-looking statements here. And I have already introduced about myself. So I'm Gyanendra. I'm working in Splunk from last 5 years, and I'm mostly into the machine learning and AI domain. So for today, the agenda which I have kept is I'll give you a machine learning overview. How do you model your Splunk data? And at the last, there will be around 20-25 minutes demo. So what I've done is I have already recorded the demo for this meeting, and we will go through those demo one by one. And at the end, if you have any questions around it, please feel free to ask me. All right, so Splunk AI ML vision is, it's important for me to tell everyone is that it's empowering Splunk customers, including the citizen data scientists, to leverage intelligence in their operations. So any kind of intelligence, if you want to add to your data, that's what we provide, that's what our team does. So let's talk about the citizen data scientist and why I'm talking about citizen data scientist today. So some of you might be wondering, what is a citizen data scientist? Essentially, we just want to communicate that you don't have to be a formally trained data scientist in order to take advantage of machine learning. A citizen data scientist might be an admin or a power user who can perform both simple and moderately sophisticated analytical tasks that would previously have required more expertise. Today, citizen data scientists provide a complementary role to expert data scientists, that is bringing their own expertise and unique skills to the process. So what I mean to say is that if you know a little bit of maths, you know, have a bit of stats knowledge, you fall into that citizen data scientist category. You can create your own machine learning models, or you can solve your own machine learning use cases if you have the basic knowledge about it. So let's talk about our platform first. So as some of you might not be familiar with Splunk, I want to take a minute to walk you through our offering, that is data to everything platform. Our product teams have created all the products and capabilities you need to build for the data age. Our foundational data capability is indexing, streaming, search, and orchestration, and automation. Plus we offer the solution for the IT ops, security, DevOps, and business processes. Taken together, these capabilities make up the data to everything platform. While Splunk was originally created to manage and support on-prem services, we now offer a suite of cloud-based products and solutions that are fast to get started. It's maintained by Splunk and is capable of supporting both on-prem and cloud needs. Beyond the data capabilities, we have mentioned the data age in which we live also requires new ways of interacting with data. That's why we are investing heavily in capabilities like AI and ML, which underpin our technology and benefit our users. So where can you find AI and ML within Splunk? Splunk is using AI and ML across our platform. It improves our core products, like Splunk has its own search processing language, so you can use it there. It gives customer easy to use tools like the machine learning toolkit. So I'll show you a demo at the end, which basically builds and operationalize machine learning models on Splunk data. And is also found in the out-of-the-box premium solution, which use ML to provide a solution for repeatable IT and security use cases. So some of you might be familiar with how data is brought into Splunk. I'm not sure how many of you know Splunk, but what I'm trying to tell here is getting data into Splunk is designed to be as flexible and easy as possible, because the indexing engine is so flexible and doesn't generally require configuration for most machine data generated by all of the devices. So Splunk supports all the data, whether it's unstructured, structured, or the semi-structured, so we can ingest any data. And it, like we have like control systems, sensors, SCADA networks, applications, and are like connected by industrial networks. Splunk can directly monitor hundreds or thousands of local files, index them, and detect changes. Additionally, many customers use our out-of-the-box scripts and tools to generate data. For example, the common examples include performance polling scripts on Unix host, API, and more. Once data is ingested, searches and alerts are put in place, and we can begin to transform that data into answers. Splunk's AI and machine learning capabilities are part of the many unique commands that can be used in a Splunk search. Machine learning commands can be executed from the Splunk search bar using custom Splunk search processing language, as I was talking before about the SPL, which is basically search processing language. Or you can use Splunk Machine Learning Toolkit Guided Assistant, that write SPL and execute searches for you through a guided interface. You can also onboard data directly from any application or device, opening up new types of machine data to the benefits of Splunk analysis. Now, what is possible with your Splunk data? ML can actually help you leverage your existing Splunk data to do even more. To break this down, I would like to think about using data you already collect to help you with three common scenarios. Now, the first one here is outlier and anomaly detection. This may include deviating behaviors or unusual changes. The second one, I'm talking about the predictive analytics, which is basically to include things like forecasting and predicting events or spikes in behavior, or possibly early warnings of failures in the context of predictive maintenance. The third one, or the third category, is the data clustering. This is basically to correlate events or reduce the noise of alerts by grouping them together. So imagine, if you see these first two, this is basically where you find the data labeled. In terms of the machine learning, I'm saying when you have the data label, you can find the anomaly detection, what was not there in the past, now you can see in present. So it can detect an anomaly. Same case is with the predictive analytics, but with clustering, it's kind of unsupervised, where you are basically grouping the events, that is like to like. Machine learning can offer great benefits, but we have to build models before we can take advantage of those benefits. Splunk offers the ability to experiment with and model data you may already be tracking and monitoring, such as event and metric data. You can build models to apply machine learning to your IT, security, and DevOps use cases. Guided workflows and assistant found in the Splunk machine learning toolkit, which I'm going to show you very soon, can help you build different models to help you derive more insights from your data so you can ultimately make it faster and take more informed decisions. So what is Splunk machine learning toolkit? So imagine Splunk as a platform, like like for example, imagine it is an Android platform or an iOS platform. On top of it, you can have multiple apps. Similarly, machine learning toolkit sits on top of Splunk platform. It leverages the power of the SPL, and also it has guided workflow which helps in deriving, which helps customers to build models. So the Splunk machine learning toolkit app delivers the capability to operationalize machine learning models on your data and is available with any Splunk Enterprise or Splunk Cloud license. Specifically, the ML Toolkit includes a family of smart assistant, which I'm showing here, to help you experiment with common ML patterns in Splunk data, including forecasting, clustering, and outlier detection, as I was discussing in the previous slide. The MLTK, the machine learning toolkit's simple interfaces removes barriers for ML exploration, simplifying data analysis, and providing ML access to users without a formal data science education. So if you remember in the beginning, I was saying about citizen data scientists. So what I'm trying to say here is what machine learning toolkit help users who are not data scientists to build and operationalize their model. These smart assistant and other guided workflows available with ML Toolkit cover top business use cases, such as monitoring security logs to predict potential threats, and more use cases in the IT. Today, we'll focus on these assistants and show you how to build a model. Before I show you the demo, I want to take a moment to provide a high-level overview of how to build a model. The first step is to determine the goal of your work. That is, identify the problem you want to solve using machine learning. So remember, not every problem is solvable by machine learning. So you should know your use case, what you're trying, like you're trying to predict, you're trying to forecast, or you want to cluster something. Then it falls into the machine learning categories where you can use the out-of-the-box algorithms. Otherwise, you can also use the normal stats command to work on your use cases. Now, coming back to the slide again. So you have to identify the problem you want to solve using machine learning. Once that's clear, explore the relevant data and clean the things you don't want to use building models. Look, when you are ingesting data, there's so many things which is you don't require. Those are noise. So you have to actually clean it. And in fact, if you see, that is the 80% of the job. Like if you're trying to build the model, the 80% of the things is about cleaning the data. And that's where the most of the data scientists spend their time, or rather today it's called data engineering. This is the most important step, by the way, in the machine learning workflow. Once you're done with the data cleaning, you can apply the algorithm, evaluate your result as per your use case. Once satisfied, you can deploy the model into production. And this should be a continuous process as the model needs to be retrained with the new data coming into the system. Continuous learning will lead to more effective result. With that, I'll start my demo. So basically, it will showcase the smart assistant capability of the ML Toolkit and how easy it is to build the model. So let me just move here and let me go just a moment. All right. Can you? Hey, let's demo with a couple of use cases. The first use cases which I'm going. Sorry, just pause it. So can everyone hear it?
Yes.
Okay. I'm just taking pause, maximizing it so everyone can see it, and starting now. Going to show here is on smart forecasting, and then we'll move to the smart outlier detection. Now, for the first use case, it's about an e-commerce platform wants to check the count of login to its application and forecast the number for next 30, 60, or 90 days. The goal here is to make sure the system has enough resources for the days where there will be higher number of users logging to their system. So for this case, I come to the ML Toolkit, come to this, open the Smart Forecast Assistant, and create a new experiment. It brings me to the page where you can define the data. Now, in my case, I'm going to define the data using search, but you can also define the data using the data sets and metrics. As a user, I want to see my data first before moving to the next stage. So I can see my data is from April 2018 to January 2019. Once done, I'll move to the next stage. In this stage, I want to forecast the logons, which is basically the count of logins per day. But wait a second, what about special days? The days about the bank holidays, the Black Friday sales, or the other sales launched by the company itself. So for that case, what I will do is I'll create a lookup file which has all those dates mentioned, as you can see from here. And now I'll take this lookup file and join it here. I give my lookup file name, time field in the data, time field in the lookup, and add field from the lookup. In my case, I want to add the holiday value and the holiday name. Once done, I can click on join. Now you can see it has joined the days, the special days, and now I'm ready to forecast. Now I'll select the logons. I'll give 0 as the holdback period. You can see the tooltip, which actually tells me what it is for. Basically, it's for validating the model. And going back to my use case was forecasting for the next 30 days. I'll take this as an option and click on forecast. This takes a couple of seconds based on the data. Now you see a warning message here. This message is telling me there were some null values within the data, and the algorithm itself imputed them. That is, you don't need to make them continuous. The algorithm is powerful enough to do it. Now, we have the data. Now, the thing which you see over here is the SPL. Now, this whole thing has been built by the Smart Forecasting Assistant. Now, I move on to the next stage and review my stats. In this stage, You can see the R square value and the RMSE values. Now, I also want to see, instead of mouse hovering to my forecast, I want to see what is my forecasted value at certain day. It says no data available. I'll move to other day. And now I can see that the forecast for that day was 143.63. Now, my use case, one of my main points of the use case is when it's going to violate the threshold. So imagine a situation where I want to see when my logons would be greater than 100 a day. So now in this case, it clearly says there will be a violation in one day, and you can actually review it and act on it. Now, as a user, I have got the days, the forecasted value, and the RMSE. So what next? I'll save it. I'll move to the next stage. And now I have an option to operationalize my model, which is basically the outcome. So I have the 30 days of the data. If you go back to the use case, I have the 30 days of forecasting. And now what I'll do is basically I'll create some alert. And then I'll also add the machine learning conditions. If the value of the logons is greater than 100, just alert me. Now, once this is done, as the new data is coming in, I want to make sure that this always runs on the incoming data. So I schedule a model training, which will keep training my model as the new data comes in. This saves a lot of my time, and I'll always be getting an alert for any kind of overusage for the number of logins. Now, we have done the smart forecasting. What's next? The other most popular examples which I have seen which people use is the outlier detection assistant. So let's take another use case where a system admin wants to find the outliers in the call volume at the call center coming through different sources. He wants to check the outlier by day of the week, like what's there from Monday to Sunday, and wants to see from which source we have the maximum outliers. For this purpose, I have already created an experiment. I'll walk you through it. So I check my data, and the data I can see it's a time, it's a count, and you can get different sources. Now, once I have seen my data, I'll move to the next stage. Just a note, I'm using the inbuilt data which comes with Splunk ML Toolkit. Now I can extract time. As I was talking about, I want to get the outliers by day of the week. So what I'll do is I'll run the extract time, which will basically get me the data. You can already see this data over here because I have already run this experiment once. But now it will show you the different data which you can extract, like by day of the week and the hour and everything and other stuff. As you can see from here, you get the hour of the day of the week, day of the month, and month of the year. Once done, you have already applied the extraction. Now let's go into the next stage where I want to analyze the count of calls coming in, and then I want to find the outliers by day of the week and different sources. You can also see the SPL which has built. So the smart outlier detection actually makes it very easy. Imagine writing everything by the SPL. Now we build the SPL, the entire thing has been built by the smart assistant. Now, an easy button, we click on the detect outliers. It will take some time. You can also look into the history stuff, which gives you a side-by-side comparison for the different times, for the number of times you have run the experiment. And you can load them by running the same model again. You can go back to the same model back. There it is. Now, it has been grouped with the top 3 different groups to the most outliers. You can actually have a combined view or the split view. And I want to see the outlier by the time. Now, so the time it loads, you see the total number of outliers which is coming as 22. Now I want to see where are these outliers coming from which group it is coming. So there are 22 outliers coming from the SGI source. There's 0 outliers from the active agents and from the call volumes. So now I've seen it, and now actually I can move to the next stage where I get the model summary, cardinality histogram, if I want to see that, distribution properties, and the outlier analysis. This is the most important step here for the outlier analysis, which you can see there were 9 outliers on Thursday, 6 outliers on Sunday, and 5 on Wednesday, and 1 respectively for Monday and Saturday. And all the outliers are coming from the SGI source. Now once done, we can move and we can just save it. So now we have done with the 2 most popular cases, and you have seen it's how it's easy doing through the smart assistant. If you want to look into similar use cases, you can look into our showcase examples. We have redesigned the showcase examples, and it is now easier to navigate with a modern and intuitive UI. With the new showcase, you can easily filter examples by ML operation, industry, or drill down to the example for a specific use case. Like in this case, you can go into the predict fields, look into the feature examples and the other examples. Similarly, you can go into the industry and you can see the number of examples it has. And for each of them, if you see, we have labeled them, whether it's an IT, whether it's for security and all this stuff. So keep looking into it. Happy Splunking.
All right. So this was like, can you guys hear me? Can you guys hear me?
Let's demo with a couple.
Hey guys, can you hear me?
Yes.
Okay. I think someone has, okay. Sorry, I was not seeing the chat. So I have 2 more examples, but before I move to the second and third example I want to do, I just want to take a pause. I want to make it interactive. I know we have a time limit for 6:35. Any questions so far?
Yep. Any questions? Feel free to post on the Q&A or the chat. Nope.
Yeah, I know for some of them, the Splunk might be new or you might have not used it. But in a nutshell, what happens is imagine it like you have all the data at one place and you have the power of retrieving those data using some query language. And then you can basically clean those data through different methodologies. But from machine learning perspective, I'm not trying to say that use this assistant or use this one. All I'm trying to say is what is the machine learning cycle here and how it can be made so easy. So this is just one way of showing it. And I'm going to show you a couple of more examples to make it clear how we do the prediction and the clustering. So the examples will follow, but please feel free to ping me, or you can also send me your questions later. I'm happy to address those one also. All right, so I'll share my screen again and just give me a second.
Hello all, I'm going to demo the new Smart Prediction Assistant
which was released in ML Toolkit 5.2 version. But before we jump to the demo, let's talk about the use case first. An IT admin wants to predict its disk utilization before it runs out of space, as 30% of the incidents are due to low disk space. The admin wants to receive weekly email from the prediction report showing servers projected to run out of space, and based on it, request a ticket for adding X amount of space into the servers. This will help in reducing the overall MTTR. Also, he wants to do a what-if analysis on the predicted data, that is, looking if a disk runs out of space in 1 month, and if I add 100 GB, how much time will that buy me? Now let's show this with an example here using Smart Assistant. For the purpose of this demo, I have created an example using the sample data, which comes with ML Toolkit, but you can change the search with your index data. Smart Prediction comes with auto prediction algorithm that automatically checks the type of field you want to predict, that is numerical or categorical. This example uses the Smart Prediction Assistant to predict disk utilization using disk access and disk block as a dependent variable. Let me give you a walkthrough of each of these stages. The first stage is the define, where you can define the data you want to use for building the model, and we have given 3 data sources for it. You can either use search, dataset, or metrics. For this example, I'm going to use the search option. In each of the section, we have a preview section and a visualization where you can look and visualize your data. Once you have cleaned your data, you have seen your data, you can move to the next stage, which is the learn stage. Here, in the learn stage, I have an option to pre-process my data. If you want to standardize your data or normalize your data, you can use any of these algorithms. Now, as stated before, I'm going to use total disk utilization as the field which I'm predicting, and my dependent fields or the predictor fields are going to be total disk access and disk block. There is an option to change the training and testing split, and also if you are an advanced user, you can fine-tune the algorithm. These are the different parameters, and for each of them we have a tooltip. Now let's predict the disk utilization. So as you can see, while it's predicting, we are having 3 different tabs, where the first one is the input. It comes from the data which you have sent for building the model. The second one is output, where you can see the total disk utilization and the predicted total disk utilization. And the third one is the evaluate, where we have the 3 section where it gives you statistics on the R square and the root mean square, a scatter plot to show how good the model is, and the residual histogram. In this case, the predicted data is very close to the linear line, so the model is good. And you can also see we are building the SPL for you. Once you are done with the learning stage, you can move to the next stage, which is called review. Here, in this stage, we have the 2 things. The first one is the predictor importance, which shows how much important is your predictor variable. In this case, we can clearly see that total disk access is much more important than the total disk block. In real world scenario, you can have multiple variable added to it and you can check the predictor importance for each of them. The second one is what if analysis. So if you remember, I was talking about the use case in the beginning where the customer was trying to see what if I add another 100 GB of data into it and how much time I will get. So for that, here is an example. You have the total disk access, like the total value is between 0 to 822.92. You can play around with it to see how important it is and if how much will be my predicted value if I change it. For example, if I move this to 676, click on what if. What it does basically, it applies the model on the new data and gives you the new value out of it. You also get to see what's your use case in the plain summary English sentence at the top. Now, let's move on to the last stage. You save it, you go to the last stage. Now, this stage is operationalize. You have done all the hard work for building the model, and once you are happy with the result, move the model into production with all the options available here. You can create alerts. And you can say if my predicted value is greater than.
I'll just take a pause here because this is already I've shown you in the last video. So I just want to make this session again interactive. Guys, if you have any questions, do let me know before I move to my last demo on the clustering. So put it in the chat. I can see that if you have any questions around it, I'd be happy to address it.
I think we can move on. I don't see a question.
Okay. So that's an indication if the people are following it or not, or I just want to make sure that everyone is following here.
Yeah, I think there are a number of folks that are familiar with Splunk. At least I know one person in the audience.
Okay. So I'm just moving on to my last demo. So as we have talked about the forecasting, we have talked about the outlier detection. We have also talked about the prediction. The last one in the group is the clustering. So this is which I was talking about is on the unsupervised learning, where you don't have any label data. So how do you want to group the similar events? So this is just one of the examples which I'm going to show it now. Just one.
In the last demo, we talked about Smart Prediction Assistant, and here we'll be talking about another one, that is Smart Clustering Assistant. But before I jump to show the demo on it, let's talk about clustering first and its use cases. Why do we need clustering? Clustering in itself isn't always a use case, but if I'm doing analytics or trying to do some kind of event correlation or figure out like who belongs to what group, it's very useful. Clustering can be very powerful for what's called exploratory data analysis. So what we typically do with clustering in Splunk is taking a bunch of data where I don't necessarily know its structure or I don't know how things are related to each other. And that's where I would use clustering for. It helps to tell me a little bit more about the structure of the data and how things are related to each other. For example, does this person A belong to cluster 1 or cluster 0? A note here, using ML Toolkit Clustering Assistant, you can take an infinite set of dimensions of a data and then using an algorithm called PCA can compress it into 3 dimensions. Let's talk about a use case where if you imagine I take a bunch of demographic information about my user accounts, like what's their job function, what ad groups are they in, how often do they log in or authenticate during the days or windows. And I can use those features to do clustering in a way where I can identify users who are behaving similar to their peer group, that is people who are in group 1 are all behaving the same way and these people have the same job function. Another common use case would be in fraud detection. For example, We have users clustered into different groups with the same behavior, but the account has been hijacked. The fraud is determined by looking at the user whose behavior is different from the users in the other groups and is also not part of any of this clustered group. This helps in identifying the fraud or the outliers. Now, let's jump to the demo where I'm going to showcase a use case where we will cluster houses by property description. The description contains median house value, crime rate, distance to employment center. In the define stage, we can select and preview the data you want to cluster. You can pull in data from anywhere in the Splunk platform. You can use search, dataset, metrics, but for this demo, I'll be using the search. Once the data is selected, you can preview and visualize it. Let's move on to the next stage, which is learn, where I have an option of adding the pre-processing step. As you remember, I was talking about compressing the data using PCA. So you can have infinite dimensions, but you can compress using the PC algorithm. Similarly, you can use the standard scaler for normalizing the data. Now, coming back to our use case, I have selected these three fields: crime rate, distance to employment center, and median house value. I'm going to give number of clusters as 4. Smart clustering uses the k-means algorithm, which has following advantages. It's computationally faster than most other clustering algorithms. Simple algorithm to explain and understand, produces tighter clusters than hierarchical clustering. Now I have input the number of cluster. Let's click on the find cluster. Just a point here that you can also add a note here, like what you're basically creating a cluster over here. And now on the right, you see we have the 3 same tabs: input, output, and the evaluate. In the evaluate section, we're giving a couple of options to visualize it. You can either use a 2D scatter plot or a 3D scatter plot. And let's look into each of the clusters. So for the x-axis, I'm selecting the crime rate. Y-axis, I'm selecting the distance to employment center. And in the third axis, I'm selecting the median house value. Once you have selected it, you can see we have the cluster, all the cluster groups available here. On the right, you can see the cluster 0 to the cluster 3 information. You can click on each of them to see where are these points. And also on the top, we have the silhouette score, which helps me in telling that how good is the cluster. So as you can see from the tooltip here, anything which is between from -1 to +1 is indicating a better clustering configuration. We have also built the SPL for you. Once we have done with it, once we have looked into it, you can also click on one of the points to see how your data is. Here, in this, you have the median house value, crime rate, distance to employment center, and the cluster distance with a cluster ID. Let's go back to the Smart Clustering Assistant. Now let's click on the next. Use the review stage to explore the resulting model and assess your clustering results prior to putting the model into production. There are 3 panels in this stage. The first panel is the number of clusters. Here you can review the details of cluster points across all or within the individual cluster. Then you have the inter-cluster distance, which helps in examining the relationship between the found clusters, that is the average, maximum, and the minimum distance. And the third one where I'll set it as 238, set distance, is called intra-cluster distance distribution. I'm setting a distance from the centroid within a cluster to find the outliers. Now, here, if you can see here, it has detected there are 5 outliers, and clicking on it will show you a table like why these are outliers. So anything which falls outside the 238 point from the centroid distance is an outlier. So we can see the different cluster properties also over here, the cluster 0 and its distance. And now, once you're done with it, looking into it, you can save and go to the next stage. In the last demo, I talked about operationalizing the model. Similarly,
I'll stop it, and I think there's some questions. Can we use different algorithms in building the model? Yeah, definitely. So we have, so it's the question comes from Mohammed, and Mohammed, definitely you can. So out of the box, you can available. So there are 2 types of assistant inside ML Toolkit. The first one is called Smart Assistant, and there is a Classical Assistant. So in the Classical Assistant, you have the option to choose any algorithm you want. Like out of the box, you can also look at the Splunk documents. Splunk ML Toolkit documents, you can get it. And even if you don't want to use an assistant, you can actually use it within the Splunk SPL. So I hope that's fine with you. I'm just trying to, I think I did it. And the second question is again from Mohammed. Is pre-processing step mean normalizing the data? Look, pre-processing step mean different for the different things. For some of the cases, like in the outliers, as I was telling, we have given a step to extract the time so that you can split it by the time to find the outliers. In some of the cases, you need to normalize the data or standardize the data. So for each of the assistant, based on its required use cases, we have provided the pre-processing. In some of the assistant, you'll also see we have provided the TF-IDF as a pre-processing thing. So if someone is working on the text analytics and they want to break the data into words first, so they use TF-IDF also. So it depends upon use cases completely. So I think I have answered both the questions. So any other questions, guys?
Yeah, I have a question. So basically, right, what you've demoed is all the smart assistant approaches, and each of them will. You guys have already Splunk has already chosen the algorithm, the best algorithm for it, right? So there's no like like in AutoML they actually choose they actually try to find the best algorithm. They do whatever hyperparameter tuning. So all the hyperparameters is tuned already, right, for the smart.
Yes. So as I was just mentioning that there are 2 categories of assistant inside the ML toolkit. This demo only covered the smart assistant, which is like based on the number of years of experience we have in the market, and we have actually selected the best algorithms. It comes from our lab, like where we test with the different data and all those things. So we have tested different algorithms, and that's why we have selected the that's why we have selected the algorithm which is best for the use case in the smart assistant. But with that said, I'm just trying to repeat myself here. If you have any specific requirement of the other algorithms, you can definitely do it with the classical assistant. So there is another option in the ML toolkit.
Okay, thanks. Any other questions? I don't see any. So, Gyanendra, is this the last? Is that the? Are we done with the presentation?
Yes. So I'm
Oh.
actually. So what you have seen is you have how easy it is to apply ML tools to your data. So our assistant and algorithm were built with common business challenges in mind, based on use cases from real customers. So if you have an identified issue or you are just trying to get new insights from your data, Splunk ML Toolkit can help. And the sooner you get started, the sooner you can start to surface new insights.
Right.
That's what my conclusion is overall. But please feel free to ping me if you have anything. Somebody has a question. Wait. to know the model quality for each epoch, do we have any option in Splunk? So I think you're talking about mostly from the TensorFlow and the other stuff. We do have that in option. So first, this question has two parts. The first part about the model quality. So if you see in the Smart Assistant, we have included some of the scoring. Uh, hey, by the way, Chris, do I need to click on answer live and then answer it? Or
No, you can
oh,
just answer and I can click it on it for you.
okay, okay. So yeah, so the part one is there are two parts in the review stage. In the Smart Assistant, we give you these scores, and that scores defines the model quality. Also, we have something called score command. Now, what does the score command does? It's like if you have a bunch of there's so many score available for different algorithms and all those things. So you can also rate your model quality based on those score commands. You can just follow this Splunk ML Toolkit docs, or I can send it to Chris and he can share with you guys. So you can do it. The second part is about Epoch, and that is about the TensorFlow. So I would say that is an app which is called Deep Learning Toolkit, which is made on top of the ML toolkit. So from there, you can definitely see the model quality for each epoch. So definitely we support it. That is again made on top of the ML toolkit, but that app is called Deep Learning Toolkit. I hope that.
I see. So basically, would you say that this is a follow-up question? So ML Toolkit is basically the traditional ML algorithms, right? And then the deep learning toolkit would be the deep learning,
Yeah,
algorithms.
supports TensorFlow, PyTorch, Spacey, and other stuff.
I see. And one issue is usually the amount of data you have, right? For deep learning, you will have like easily 10,000, 20,000 data points.
And
but yeah.
And also the compute.
And also the compute. Okay, so how does the compute affect? I mean, is it going to cost more? Those kind of questions.
I mean, think it depends upon your on-prem infrastructure. So if you want to do it right now, it's only supported on the on-prem, the deep learning toolkit. But it completely depends upon how much how much you have in your infrastructure. If you have the infrastructure, you can do anything.
Yeah, of course. If it's on-prem, then it's basically your AWS or whatever bill. But how about the Splunk cloud? Is it on Splunk cloud?
It is there on the Splunk cloud as of now. It has just started, but that has a different license. If I'm not wrong, the licensing mechanism depends upon the compute.
Got it. So but MLTK is comes with it.
What I have seen is 80% of the use case, the common use case, is easily solvable using the ML toolkit.
Yeah.
And the very advanced use cases where you need the deep learning expertise, there people need deep learning toolkit.
Got it. Wow, this has been very interesting. Okay, any other questions? We have about 10 minutes. Going once, going twice. Well, yes. So just a quick one. So for Gyanendra, if you have any links to documentation, or if Splunk has recordings of training for MLTK and deep learning toolkit, please share with me, and I'll share with the
I'll
the audience.
share with you. I'll share the docs page. If you just type Splunk ML toolkit docs on Google, it will show you everything.
Oh, okay. Okay.
Just type Splunk ML toolkit docs. Or let me do it for you. Just a moment.
Oh, okay. Thanks.
Right away. Here you go. I'll just put it on the chat. And just a moment. Here it is. And when you install ML Toolkit, there is a tab on it where it says video tutorials. So you can literally click video tutorials, and there are like tons of videos to educate you.
Awesome.
There are like around 30 to 40 videos, and each video is just around 5 to 6 minutes. So you can actually learn a lot from there.
Perfect. Okay. If there are no questions, then I would just say thank you so much, Gyanendra. It's been very good. It's been very helpful. It's been very insightful. I think all the attendees also agree with that. So thank you again. Thank you so much for taking the time to give us this talk.
Yeah. There is a question over there. Someone said link.
Oh,
Which
the
link
link.
you're talking about, JJ? Which link you're talking about? So I'm not getting it. Are you talking about the docs link? I've just mentioned it there. Oh yes. Okay. Okay. All right, guys. So
Yep.
thank you very much for joining this session. And if you
Thank
have any
you.
questions, please do Chris know, and he can reach out to me. Thank
Sounds
you.
good. Sounds good. Thank you. Thank you everyone for attending.
Thank you. Bye bye.